topic is inverse of an element. Inverse of an element. Let A and B be two sets and function f is defined from A to B, or okay, function f is defined from A to B. We'll see here how to get the image, or sorry, inverse of an element. So let us consider this is set A and this is set B. Function f is from A to B. Likewise, say this is A1, A2, A3, A4, A5. This is B1, B2, B3, B4, B5, B6, B7, B8. These many elements are there in set B and so many elements in A. So we will see that this is also known as pre-image or domain, and set B is known as functional image or f image. F of x we are getting over here, and it will be either range or codomain, known as codomain, or both. That depends. Here range is, I'll explain little bit. Range contains B1, B2, B3, B4, B5. This is equal to, range is equal to this one, and codomain, the entire set B is known as codomain. So refer this one for range, and codomain, this is codomain. This is range, this is codomain. F of A, if I find, definitely I'll get B1. If I'll find f of A2, I'll get B2. F of A3, I'll get B3. F of A4, I'll get, that is B5, and so on. Oh, sorry, B4. So when if I consider this one only, first one, so what I'm getting is f of A1 equal to B1. If I find, if we take inverse on both sides, definitely it will be inverse B1. Likewise, I'll get. And if this is the thing, am I getting this one? So let us consider again the inverse function. F inverse B1, I'll get A1. F inverse B2, I'll get A2, as B2 is related to A2. And F inverse B3, I'll get pre-image, that is A3. F inverse B4, I'll get a pre-image, that is A4. F inverse B5, I'll get pre-image as A5. F inverse B6, I'll get B6 is nowhere related to this set A, so it has empty set, or it is just empty, so it is nothing but null. Similarly, F inverse B7 is also 5. F inverse B8 is also 5, 7, 8. Okay, so this is the thing we are getting. Now coming to inverse of a function. So let us example these two sets, and set to be, this is set A, this is set B, and function, we are operating a function, or function is given like this. So what we are doing is, from here to here it is function, and obviously here to here also we will see that what exactly is happening. So it is F inverse. So here it is x, and here it is y, and y is nothing but f of x we are getting. And if I consider this y, or f of x, so pre-image if I want to find, then definitely it will be f inverse y. This is nothing but pre-image. So if I take inverse on both sides, this is nothing but x will be this one, so I am getting the same thing. Let f be a function from a to b, be a bijection, then a function g from b to a, which associates each element y belongs to b to a unique element x belongs to a, such that f of x equal to y is called the inverse of f. That is, f of x equal to y, that implies on both sides g of y equal to x, g of y equal to x. The inverse of f is generally denoted f inverse. It is denoted by f inverse. Thus we can say, if f is a function from a to b is a bijection, then f inverse from b to a is such that f of x is equal to y, that implies f inverse y equal to x. This is the final thing. One should note it down very carefully. So we'll see some more further thing. We'll see one question over here. Question says, let a equal to r minus 3 and b equal to r minus 1. Let f is a function from a to b be defined by f of x, that is equal to x minus 2 divided by x minus 3 for all x belongs to a. Then show that f is bijective and hence find f inverse. So this is the question, and in the solution we have written the same data available in the question, that is a equal to r minus 3 and b equal to r minus 1, and the function is given as f from a to b is defined as f of x, that is x minus 2 and x minus 3 for all x belongs to a. Here f is defined for all x belongs to a as 3 does not belongs to a, Also f of x is not equal to 1, as this one is whatever we are getting from in set B is f of x is not equal to 1. Since f of x equal to 1, that implies x minus 2 by x minus 3 equal to 1. That implies x minus 2 equal to x minus 3. Further, that implies minus 2 equal to minus 3, which is absurd. So we cannot consider that one. That's why it is not it is given that r minus 1. So it is given r minus 1. So let x1 and x2 belongs to a be such that f of x1 equals f of x2. That implies x1 minus 2 divided by x1 minus 3 is equal to x2 minus 2 divided by x2 minus 3. That implies x1 minus 2 x2 minus 3 is equal to x1 minus 3 x2 minus 2. That implies x1 x2, if you multiply or open bracket, will get these values: 3x1 minus 2x2 plus 6, if you open bracket, will get this one equal to x1 x2 minus 2x1 minus 3x2 plus 6 that imply minus 3x1 minus 2x2 equal to minus 2x1 minus 3x2, that imply x1 equal to x2. Therefore we can say f is a 1 function. Let y belongs to b such that or equal to r minus 1 that imply y is not equal to 1, and what we want is we want to solve y equal to f of x for some value that is x belongs to a. We want to solve for y equal to f of x for some x belongs to a. That imply y equal to x minus 2 by x minus 3, and further if we shift to that side we'll get xy minus 3y equal to x minus 2. Further we'll get if we take common x, then definitely we'll have y minus 1, this is equal to minus 2 plus 3y, or we'll get x equal to 3y minus 2 by y minus 1, that belongs to a, as y is not equal to 1. Therefore we can say, or therefore f is onto function, that imply f is a function from a to b is a bijective function. Now f inverse y will get x, and that is equal to x equal to, we have seen that 3y minus 2 divided by y minus 1 will, we have this. So further we can solve f inverse x can be given as 3x minus 2 divided by x minus 1, and this is the inverse of the function given. So there are some properties of inverse of a function. Note down the next concept, and we have seen that the inverse of a bijection is unique and also a bijection. Whatever we are getting is unique, and also we are getting the bijection or bijective function only. Second one, if f of if f is a function from a to b is a bijection and function g from b to a is the inverse of f, then FOG, that is equal to IB, and GOF equal to IA, where IA and IB are identity functions on set A and set B respectively. Next one, that is property number 3. If f is a function from a to b and g is a function from b to c are two functions or two bijections are given, then GOF is a function from A to C is a bijection and GOF inverse can be written as F inverse O G inverse. Number 4, let f is a function from a to b and g is a function from b to a,